So thanks to our good friends Heisenberg and de Broglie, we've realized that we have no idea where the electron is going to be. The best that we can do is describe a region of space that it probably is within. So from here on out, we're going to start talking about these blurs of space that we're going to call an orbital. But what is this atomic orbital going to look like? Now, there's going to be a couple of different shapes that we can have for atomic orbitals, and this is going to be something that's pretty important as we go into the shapes of atoms and into the shapes of molecules. Let's look at what this is going to look like for the time being. Now, we'll plot it in 3 dimensions, and we're saying the electron is probably within this blob, but remember that there's going to be the residual probability that it's someplace else. That's going to make more sense in a second, I hope. Now, if we were to take a dot plot and have our nucleus right here in the center, as you get further and further out from the center along the radius, you're going to have less and less chance of finding the electron there. It's never going to drop down to a 0% chance. It might be a 0.0000001% chance, but there's still some tiny little chance. We don't care about chances that are smaller than winning the lottery. I don't care about chances that are smaller than winning a scratch-off ticket. I want to be able to describe where the atom exists. And that electron is part of the atom, so I don't want to just shrug and say, it's somewhere in the universe. I want to have something that's a little bit more useful of a definition than that. Now, I also don't want to be so useless that I come all the way in here and say, yeah, there's like a 30% chance that the electron is somewhere in here. That's not very helpful either. So what we need to do is we actually need to have some sort of a plot where we say, how likely is it that it's within this radius? Now, at each of these spots, you can take something called the wave function. You're not going to deal with wave functions in this class, beyond knowing that there's this mathematic way of describing this. And if you square it, you get this plot that shows probability. And if you go take a physical chemistry course at the higher level, you'll actually talk about some of these higher level statistics and higher level physics that help us describe what's really going on in here. Be warned, that typically means Calc 3. But if you don't mind that, it is an interesting little bit of learning. Now, as you get further and further out from the radius, yeah, it starts dropping toward 0. But if you remember from your calculus classes, this line is just going to continually approach 0 without ever quite getting there, despite the fact that my hand keeps bumping toward it. Right, so instead, we can say, right, let's have some sort of a cutoff distance where we say the electron is usually here. Well, that's not a terrible thing either, right? If you're looking for me for office hours, you're going to try my office. Did I maybe go out for coffee because I ran out in my office? Sure, that's a possibility. But from 9 to 5, you expect to find me probably in my office. And that's a reasonable guess. That's what we're talking about when we draw an atomic orbital. Now, here all the way inside, you see a 10% chance. Way out here, there's a 50% chance. But still, we're really flipping a coin, aren't we? Literally. Now, notice also that we've got this weird little feature here. You'd expect that as we get closer and closer to the nucleus, we'd expect it to keep going up, but all of a sudden the probability drops back down. Let me remind you of why. We still have a nucleus in the center right there. And if you get too close, your electrons are repelling each other, if you have more than one. And if you only have one electron, don't forget it's still not allowed to occupy the same space as your proton and your neutron. So there's effectively a 0% chance that it's inside the nucleus. Now what we're going to typically do is draw a ball where we show a 90% chance of finding the electron within it. So that's going to be the interval that we're going to use for most of these sketches you'll see going forward.